Students, hello, 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 hello. Are we getting set? Are we getting set for today's blast? If you are online and you can hear me well, say yes. Can you hear me? Are you online? Let's get set. Let's get set. Let's get set. Let's be getting ready. Let's be getting ready. It's almost time. 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 Hello. Hello. Are you online? Hello. How is it? Are you online? Good afternoon. Good afternoon. How is the position of the camera? Can you hear me, please? Tell me if you can hear me. Can you hear me? Hope the camera is not laterally inverted today. It's blurry. That could be that could be network. That could be network. Can you hear me? Can you hear? Fine. What about the position of the camera? Okay. You can hear me. What about the position of the camera, please? Hope is well positioned. Hope is laterally inverted. Or hope is not laterally inverted, sorry. Okay. You can't see the board. The camera is not positioned well. How is it like this? It's a bit slant. How is it like this? What about this? Good evening. What about this, please? Check. But can you hear me? Not laterally, fine. Okay. Can we go? Can we start? Are we good to go? Are we good to go now? Tell me, say yes, say yes. If we are good to go, it's okay. Okay, good to go. Beautiful. Thank you very much. Thank you very much. This afternoon we are basically going to discuss some applications of differentiation. We review differentiation as well, and we look at certain areas where we need to apply differentiation in calculus. So without wasting our time, because time is money, let's recall. We recall the differentiation. You know, if y is equal to x raised to the power n, if we are asked to find the differential value of y, which is dy, with respect to x, the basic thing is we take n, we multiply it by this one, that is n, then we write x, and we take 1 away from this power. So this is the basic formula for differentiation. Okay, are we seeing it? Can't see the board. Can't see the board. Why? You can't see the board? You can only see what? You should be able to see the board now. Hello? You can't see it. You can't see the, where is the board? The board is there. Hello? You can only see me. That's quite unfortunate. Switch the camera. How is it now? Can you see the board now? Can you see the board now? Can you see the board now? Okay. Can you also hear me? Oh, beautiful. Now, what I said before was the basic definition of differentiation is if y is equal to x raised to the power n, you differentiate y with respect to n by saying that dy dx is equal to take n here, which is the exponent, used to multiply the coefficient of x here. 1 multiplied by n is n. Then subtract 1 from this n. It gives you n raised to the power 1. That is n multiplied by x n raised to the power 1. I hope you can see me and hear me clearly. Oh, beautiful. Thank you very much. Thank you very much. So let's go. Now, this is the basic definition of differentiation. This is the basic formula. Now, if we have y is equal to x plus, let's say, 1 raised to power n, this goes to what we call function of function. And so, applying the same principle, that is the basic formula of differentiation, it will be dy with respect to dx will be, take your exponent here, you to multiply the coefficient here, you have n. Now you differentiate what is in the bracket with respect to x. It will be 1. When you differentiate x, you are going to have 1. So multiply by 1, then open the bracket again and write x plus 1. Subtract 1 from this exponent. You have n minus 1. So we have what? N into x plus 1 raised per n minus 1. This is an example of function of function. I hope we, okay, very good. I hope we are following. Okay, this is we are just starting. Now, by chain rule, which we are familiar with, you call it function of function. You know, dy dx could be dy du multiplied by du dx. Okay. Now, these are the basic, formula for chain rule or application of function. Don't forget, we have started with the basic definition and formula of, of differentiation. All right. Now, having said this, let's go to the area of application of differentiation. The areas of application of differentiation. Area of application of differentiation, which we are going to discuss this afternoon. Area of application. You can't see the board. It's blurry. That could be network problem. You are seeing my face, not the board. Oh, wow. How about the board now? Can you see the board? Okay, you can't see the board. That's unfortunate. You can't see the board. You can see it. Okay, you can see it. The camera is blurry. You can see the board. The video is not clear. It's just blurry. You can't see the board. You can see it now. Okay, perfect. You can see it. Okay. Please, that is network problem, please. Please bear with me. That's a network problem. Now, the area of application we are going to discuss this afternoon, one, we have as a rate measurer, that is differentiation as rate measurers. Two, we are going to discuss the application of differentiation in kinematics. That is a movement of a body in a straight line. We're going to discuss tangents, and normal to a curve. We are also going to discuss maximum and minimum value of a function, and eventually we are still going to discuss points of inflection. Please check. Can you see the board? Okay, you can see the board. You can't hear. Check your network there. It will be there. It could be where you are, please. You should be able to hear me clearly. Okay. Now let's look at examples. Let's look at the examples to establish all this area of applications that we have listed. Let's look at examples to establish them. just to illustrate the areas of application that we have listed there. Let's look at the examples. How is the clarity of the board now? Is it still blurry? You can't see. It is that should be network. It's perfect. No, sir. Can you see it? Should I change the network? Let me try to change the network, please. Please. Oh, okay, perfect. Blurry, not fair. Okay, let me change the network, please. Let me change the network. It's blurry. Which one should I follow now? Is it blurry? Please change. Okay. Let me change the network, please. It's okay. It's blurry. It's okay. It's good. Which one should I follow now? Is it good? It's okay. Let's continue then. Let's continue. Now we want to look at example 1 under rate measurer. Example 1. Want to look at how derivative could measure rates. So with this, we shall discuss this example that says at what rate is the area of a circle changing? This is a very good example. Changing with respect to its radius. When the radius is 1 centimeter. That's a very good question under the area of application of derivatives or differentiation. So this one is giving us an example of how derivative can be used as a rate measurer. Now, to solve this problem, let's look at what we are given as parameters. At what rate is the area of a circle changing with respect to its radius? Area, let A represent the area of a circle, okay? And the R be the radius of the circle, all right? There's a connection between the area of a circle and the radius of the circle. That connection is the area of a circle is equals to what? Is equals to pi r square. That is the formula for area of a circle. So you can see that area of a circle connects pi and r. So now, the question now says, at what rate is the area of a circle changing with respect to its radius? That implies that the rate means the A, the R. We are asked to find the A, the R. That is at what rate? Derivative is the rate of change of something with respect to something. So now the rate of change of the area of a circle with respect to the radius will now be dA all over the R. So that differentiates A with respect to R. So you bring 2 here, 2 times 1 here, you have 2 pi. Now you remove 1 from these 2, that is R. So that's the rate at which these the area of this circle is changing with respect to its radius. Now the question I ask further, when the radius is 1 centimeter, that is, what rate will that area of the circle be changing with respect to R if the radius is 1 centimeter? And you know that our R represents the radius. So now we have the A, the R will be 2 pi R. Our R here is now what? Is 1 centimeter. So that will be what? 2 pi. Because 2 pi times 1 is 2 pi. Now the units, we are talking about area over radius. That is centimeter square per centimeter, because area is a measurement in 2-dimensional, plane, so it has to be square. Area is measured in meter square, centimeter square, and the like. So while radius is just 1-dimensional, that's why it is centimeter. So with that, you can't see anything. It's blurry. This is the network. This is the network problem today. This quite. It's not clear. Blur. Okay, let's give me 2 minutes. Give me 2 minutes. Let me adjust the network. Let me change the network, please. Let me change the network, please. Let me change the network. Let me change the network. Now, how is it now? How is it now? Please check. It's still blurry. How is it? Is it okay? It's blurry. It's very blurry. What about this? Very blurry. You can't see. Can you see my face now? Very blurry. Better. How is it? Can you see the board? The camera is facing me, so you cannot see the board. Okay, let me clean the board and check whether you can see the board now. Can you see what I'm doing now? Can you see what I'm doing now? No, you cannot see. So you cannot see the board again. Can you see? How about this? Can you see the board? That's the question. Can you see the board? How is it now? You can't see the board. God mercy. Let me write something on the board and tell me what you can see. Let me write an example on the board. Let me write an example on the board. Let me write an example on the board. let me write this. So we now judge with this. Let me write this example on the board. The radius of a circle is increasing at the rate of 0.1 centimeter per second. Can you see what I wrote there? Can you see what I wrote there? Some of you will say it's okay. Some will not say, I don't know. You said you keep saying that you are seeing my face. You can't see the board. We are seeing your chair. No, sir. Better, sir. Can you see the board? That's the question. Can you see the board? Switch again. Switch the camera again. I'll switch the camera. No. We can't. Better now. No. How is it? Can you see the board now? You can. It is the network problem. The network problem is the main problem we are facing, not anything. It is network problem. So you can see the board now. Okay, better. Thank you. God bless you. So now the question says, at what rate? At what rate? At what rate is the area? At what rate is the area increasing? At the instance when the radius r is 5 centimeters. Can you see that? Are we good to go? It's too close. Can you see now? Can you see now? How's the visibility now? Can you see the board now? Okay, you can see the board. You can see the board, right? Can you see the, yes, okay. Now, the question says the radius of a circle is increasing at the rate of, 0.1 centimeter per second. So now, how do we solve this? Radius is increasing at the rate of, you can see that the radius is measured in centimeter or meter, but here it is in centimeter. It's now increasing at the rate, and the rate means the proportion of radius with respect to time. You can see that this particular value, 0.1 centimeter per second. That is the r, which is the radius. The t is given to be 0.1 centimeter per second. That is the radius. I mean, that's the rate of radius with respect to time. Now, the question is now asking, at what rate is the area now increasing at the same instance when r is 5 centimeter? Okay. Now this time around, now we want to find the a, the t. That is, we want to find the a, the t. Okay. The question is asking us to find the a, the t. Okay. Now, are you still seeing? Okay, very good. Now, how do we now find the a, the t here? How do we find the a, the t? Now, you can see that from here, we have the a, the t, using our concept of chain rule, could be what? From here now, the a, the t could be the a, the r, times the r, the t. Yes. How? How did I get this particular formula? Now you have been given the R dt. That will be constant. Now, for you to get the A dt that you are asked to find, you have to think of a rate, the rate you will use to multiply this the R dt. That will give you the A dt. And you know that you are given the radius of a circle. So we need the area of a circle in this calculation. Now, since area of a circle is pi r square, you know, now differentiating area with respect to, that is finding the derivative of a with respect to r, give us what? The a dr. And the a dr here is, you know, just like the previous example, 2 times 1 here, you have 2 pi, remove one from these 2, you have r. So our dA dr is 2 pi r. Okay, now you don't understand? You should try to understand. Okay, let me go back again. The radius of a circle is increasing at the rate of 0.1 centimeter per second. This value given to you is telling you that we have a proportion of radius r all over radius with respect to time. Time is measured in seconds. I hope you understand. So, and radius is measured in centimeter. That's why you have 0.1 centimeter per second. That means radius over time. Okay, that is the given question there. So, but the statement says the rates, you can see at the rate of, so whereas we are talking about the rate of change of radius with respect to time, that's why we write the r dt. It will be this. Now, the question is now asking, at what rate is the area increasing at distance when r is, first of all, if we are being asked at what rate is the area increasing, that means the a dt. Rate has to do with time. So that means we are looking for the a dt. And invariably, you've already gotten the r dt, which is this. So what are we going to use to multiply the r dt that eventually to give us the a dt? Obviously, you know, if you multiply because why are we choosing the a dr? It's because in our given formula for area of a circle, the area of a circle is pi r square. So that means that we will need the rate of change of area with respect to the radius. So from here we get the a dr. That's why we write the a dr times the r dt that was given. If you multiply these together, it will give you the a dt that you are looking for. Because the r will cancel the r here. You left with what? The a dt. Okay? And the a dt, if you differentiate, we give you 2 pi r. That is 2 multiplied by pi here, 2 pi. Then subtract 1 from here, you have r. Are we good to go? Are we good to go? Are we good to go? Are you getting it? No, you're not getting it. Network again? Yes, okay. If it will equally depend where you people are. You know, where you people are watching this live video could also affect the visibility. Take note of that. So we have gotten the a dr to be 2 pi r, and we are looking for the a dt. Okay, we are looking for the a dt. How do we get the a dt? Fine. Since the a dt is said to be what? The a dr multiplied by dr dt. So, and our the a dr now, that is the a dt, will now be equals to the a dr, which is 2 pi r multiplied by the r dt that was given to us is what? 0.1 centimeter per second. That is the value of the r dt that was given to us. Okay. Now, if you multiply that, you are going to have 0.2 pi r. Whereas in the question, you are given that the radius will be 5 centimeters. So that means 0.2 pi times 5. So by the time you multiply this, you're going to have 1.0 times pi. That is pi, because 0.2 times 5, that's 1.0. Times pi, that is pi. Remember, it's the area, the t, that is the area, the time. Area is measured in centimeters squared according to the question. Then time per second. So the answer there is pi centimeters squared per second. How is it now? Can you still see? Can you see? See there? Are you following? Yes, okay. No, see, the problem is the geographical variation could affect the visibility. You might not, your network there might not be as good as mine. Mine might not be as good as yours. So let us try to bear it like that. With time, there will be improvement in the network or movements. And I believe we'll make it clearer as we go on in the teaching. So please, bear it. Okay. What is important is, can you hear me and can you see what I'm writing on the board? If you can see both, then every other thing is going to improve. If you can see the board and you can see what I'm writing, that will be very good enough. So you can see I'm trying to adjust the position of the board so that you see clearly. How is it? Okay. All right. Is it better? Can we continue? Okay, good. Thank you very much. Now, so that is one of the applications of derivatives or differentiation. Now we move to kinematics. That's another area. Kinematics. Now, under this kinematics, we talk about the movement of a body in a straight line. Now, suppose a body moving in a straight line. Let's say a body moving in a straight line traveled a distance. Let's say a body traveled a distance s after the time t. So we have two parameters, x and t. Then the rate of change of that distance s, with respect to t, with respect to time t, will be the speed v. Will be the speed v, that is the rate of change of distance with respect to t, will be the speed v of the body. Maybe you can still remember that your length in physics, the rate of change of distance with time is equals to velocity. So the speed, of the body v will be the rate of change of distance over time, ds dt. Can you see? Can you see it? Should we continue? Can you still see? Are you writing on the board? All right. Okay. Now, similarly, you can also discuss the acceleration. Similarly, you can also discuss the acceleration in terms of the velocity. You can discuss the acceleration of the body in terms of its velocity. Now, suppose we want to discuss the acceleration of the body. Now, similarly, the rate of change of the speed now, the rate of change of the speed with respect to time t, with respect to time, will be acceleration A. You have learned this in elementary physics, okay, of the body. That is, A now will be change in the velocity, dv dt. And don't forget your dv, your dv is the velocity change or the speed all over time. And our v is the rate of change of distance over time. So this one will now be what? D dt into bracket ds dt. How? Why? Good. The rate of change of the velocity with time is like a second derivative for the rate of change of speed with time. Because, v originally from the last explanation, from the last statement, is ds dt. Now we want to find the rate of change of v. So that means we are going to find derivative of v with respect to t as well. So A is that derivative of t with respect to t. And so that means the v dt will now be d dt. That is, we want to differentiate this velocity again. That's what it means. D dt of ds dt, where ds dt is already your v. So if you take your v away here, if you extract it, you have d dt, then your v is ds dt. Just like, it's as simple as that. If you extract v out, you have d of dt, ds dt, which will give us what? D square s all over dt square, which means that acceleration is equals to what? The square s over dt square. I hope, can you see? All right, so thank you. Now that is that for acceleration. Now on the alternative as well, another way of writing acceleration, we can write it like this. Acceleration, we know that is equals to the v dt. If acceleration is equals to the v dt, now using the concept of function of function, we can say the v ds multiplied by the s dt. How? Fine. Okay. Now, you know that we said acceleration is the rate of change of velocity with time. So, and we know that if v is taken as our velocity, so now to really, to derive an expression that will connect the s dt with another component of derivatives, such that when we multiply them together, it will give us back the v dt. That's why we now say, okay, if the s dt has been established as the velocity, which is the rate of change of speed over time, then what are we going to use to multiply this? That by the time we multiply them out, we will get the v dt. And that's going to what? The v ds. Because velocity is dealing with speed. So we are going to find the rate of change of velocity with speed multiplied by the rate of change of speed with time. So that will give us acceleration. So those are the formula for acceleration. Now let's look at examples. Let's look at examples. Please try to bear with us. This is not the problem is not really from me. It is logistic due to network problem, and I want you to really watch this to the end, because it's going to go a long way in helping you pass your tests and exams. These aspects we have not touched it at all. I've not taught you this. I've not uploaded any video on this. That's why I deem it fit that because you'll be tested on this. To be honest to you, there are many questions that will be tested that will come out from here. So, and if you're able to understand this concept, when you see those questions, you'll find them very easy. You won't waste your time unnecessarily in the exam or test all. So let's look at the example. Example 2. Please bear with us. The network will improve. I've done all necessary things I should do here. So please, it could be from your hand here. A body moves in a straight line. A body moves in a straight line so that the distance moved, s meter. That's the distance moved. The distance is s meter. After time t seconds, that's the unit of time, is given by the equation that connects the distance with respect to time is given by s equals to t cubed minus 2t squared plus t. That is the equation. Now, the question now says, find an expression. Find an expression for the speed of the body at time t. That's the first question. 2, the second question. Find the times at which the body is at rest. That's the second question. And the third question, what is the acceleration? What is the acceleration of the body at these times? So that means the times is not 1. Now let's look at this quickly. I hope you can. Are you following, please? Are you following? Can you see? Okay, all right. Now, how do we go about this? The equation that connects the speed with time is given to what? is given to be s equals to 3 cube minus 2t squared plus t. Okay, now the question says we should find the expression for the speed of the body. Already this is the distance, and to get the speed is velocity. Speed is velocity, which is the same thing as what? The rate of change of distance over time. Okay, so that means we are going to differentiate the speed with respect to, the distance with respect to time to get the speed. So the s, the t now will be what? 3 times 1 here, 3t squared minus 2 times 2 here is 4t plus 1. Okay, that's how to differentiate. Now I think you already know how to differentiate. That is simple. Okay, now so this solves the first question, that is find an expression for the speed of the body at time t. So this is the expression for the speed of the body at time t. Now the second question says find the times at which the body is at rest. Okay, now let's look at when the body is at rest. The body is going to be at rest, when the velocity is equal to 0. Yes, when a body is not moving at all, you say the body is at rest, and it doesn't have a velocity. A body is at rest when it does not have any velocity. When the initial velocity is equal to 0, it's at rest. It's not moving. Okay, so that means, and our velocity is now what? 3t squared minus 4t plus 1. So what do? Since the body is at rest, v is equal to 0, which now implies what? Which implies 3t squared minus 4t, plus 1. So that will be equal to 0. So now factorize. Let's try 3t squared times 1. That is the 3t squared. So we are looking for the factors of minus 4t by addition. That will give us minus 3t minus t. Okay, so we now replace minus 4t by minus 3t minus t. So we have what? 3t squared minus 3t minus t, then plus 1 equals to 0. So we have factorized. We have replaced, anyway, we have not finished the factorization, but we have replaced the values in the middle term with minus 3t minus t. So now what is common here? What is common? 3t is common, so we have 3t into t minus, because 3t is here, 3t is here, 3t is common. So when you factor out 3t, it remains only 1t. Then minus 3t in 3t, that's 1. Then minus, what is common here is 1. You have 1 into t, then plus 1 divided by minus 1, that is minus 1, is equals to 0. Okay, so with that, we can now expand, we can combine them together, not expand anyway, just combine them together and equate each of the values to 0. So now have what? 3t, the one here, minus the one outside, 3t minus 1, into, take one of the one in bracket, t minus 1 equals to 0. Okay, so you now equate each of them to 0. You have 3t minus 1 equals to 0, or t minus 1 equals to 0. So 3t is equal to, this one will go here and becomes 1. So divide both sides by 3 so as to get your t. You have what? T equals to 1 all over 3. Or when minus 1 comes here, it becomes t equals to 0 plus 1, which is 1. So the time, according to the question, the time at which the body is at rest is 1 over 3 seconds and 1 second. So the body is at rest when it is 1/3 seconds and 1 second. Now the next question says, what is the acceleration of the body at these times? What is the acceleration of the body at these times? Okay, we have the time is 1/3 and 1 second. Now I have to find what? We have to find the acceleration of the body at these times. Okay, now how do we go about that? Let's look at this. Now, we got our we obtain our velocity, our speed, to be equals to, we have 3t squared minus 4t plus 1 from the initial value of speed that is given to, distance that is given to us. Initially, the distance given to us is s equals to 3q minus 2t squared plus t. This is the initial, equation of the distance equation. S equals to tq minus 2t squared plus t. And when we differentiated this, we obtained the velocity of the body as this. Now, for us to get the acceleration, that means we will differentiate again. From the previous formula I've derived for you today, the higher derivative of what we call the speed is equal to acceleration. So that means acceleration what? Acceleration is equal to what? dv dt. So now differentiate this once again. Okay, dv with respect to dt, which is what? 6t, because 2 times 3 is 6t, then minus 4. 6t minus 4. Please, are we together? Are we together? Please, are we together? Please, are we following? Are we still following? Are we still following, please? Hello, guys. Are you still following? Are you still following, please? All right. Okay. Now, 6t minus 4 is the acceleration. So now, when t is equals to 1 over 3, acceleration will be what? 6 times 1 over 3 minus 4. So that will be what? 6. This 3 here, 1, 3 here, 2. So that will be what? That will be 2 minus 4, which is going to be what? Minus 2. Acceleration is what? dv dt. That is meter squared per seconds. Meter squared per seconds. Okay. Then when t is equals to 1, because we have two values for t. When t is equals to 1 over 3, acceleration gives us minus 2 meter squared per second. And then when t is now equals to 1, we are just substituting now. So we have what? 6 times 1 minus 4. That is 6 minus 4 is equals to what? 2 meter per second square. Sorry, meter per second square. I think that should be second square. No, meter square per second, second square. Okay, meter per second square. Okay, so that is the value of the acceleration when t is equals to 1 over 3 and t is equals to minus t is equals to 1. So now we move to another application of derivatives. Let's 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 move to another application of derivatives. Now, the next application of derivatives is to find the tangent and normal to a curve. Find the tangent and normal to a curve. The tangent and normal to a curve. Now, without wasting our time, now we all know that a tangent is a line that touches, a plane shape, maybe a geometry, a geometrical shape at a point. For example, if I draw a circle now, and I draw a line, probably here. Yes, this is the point at which this line touches the circle. So if you have a curve and another external line touches it at a point, that line is called a tangent. But if it crosses like this, we call it a secant. But we are talking about a tangent. Okay? So what do we do here? Now, we want to look at how to form equation of a tangent and normal. So if we have, say for example, let's say we have a function f of x. The derivative of f of x is what? F prime of x. Now, that's the derivative of f of x. So, but suppose we have a point on the curve. For example, let me have this is a curve. This is a graph. Suppose this is the equation of the graph here gives me this curve. Let's say the curve is like this. So now, if a line from x, okay, now at this point now, it will have x abscissa, that is x coordinate, and y coordinates. Let's say x1, y1. At that point, that's the point at which the tangent touches this curve. So now, to write the equation of this curve, we just need what we call what? The rate of change of the function with respect to the abscissa x1. What am I saying? The formula is strictly say y minus y1 is equal to f prime of x, that is the derivative of the function with respect to the x1. Let me put x1 there, into bracket x minus x1. This is written as just saying that, it's like saying y minus y1 is equals to, the function, the f dx into bracket x minus x1, and the f dx is what? Is the gradient here. So which is same thing as y minus y1 all over x minus x1 is equals to the rate of change of the function f prime of x, which is the same thing as the f dx. So to write the equation of the normal, of the tangent, tangent now, you apply this. This one gives us this. It's a straightforward thing. So if you are asked this kind of question, they will give you points at which the tangent touches the curve. Then you will just have to find the derivative of the function with respect to the x axis, to the x axis, the abscissa, and then do the computation. You get your answer correctly. So if it were normal, tangent and normal have what do you call it? Inverse gradients. That is, the gradient of normal is negatively proportional. It's negative invertible to the gradient of a tangent. So what I'm saying is, if it were normal, it would be y minus y1, is equal to minus 1 all over the gradient of the gradient you obtain for the tangent, x minus x1. So this is the formula for normal, and this is for tangent. So let's look at examples to illustrate what I've been talking about. Let's look at an example. I just hope you people are following the class. Irrespective of the condition of the network, please try as much as possible to follow up, because this will help you to understand the concept better. And if you have understood it before, it's a plus for you to remember what you have understood. So let's look at a question here. The question says, example, find the equation of the tangents and find the equation of the tangent and normal of the tangent and normal to the curve y is equal to 3x squared minus 5x at the point 1 and minus 2. Don't forget, this 1 and minus 2 means x1, y1. Okay? Now, to find the equation of the tangent and normal, you are asked to find two things. Now, the given function is the curve is derived from y is equals to 3x squared minus 5x. That is the equation of the curve. Now, to differentiate, to find the rate of change of y, which is the gradient of the curve now, with respect to x, to be the y dx is equal to 2 times 3, 6, then x minus 1, that is x raised to power 1 minus 5. So this is the gradients, which is the same thing as f prime of x that I used the other time. So I can put 1 here, no problem about that. Okay, it's the same thing. This means the same thing. It's the derivative of the curve. So now, using the question now says that, I said I wrote f prime of x1. That means I have to substitute for the value of my x with respect to the abscissa point on the curve. The point of the abscissa here at the x-axis is 1. So that will be what? 6 times 1 multiplied by 5. Minus 5, sorry. That's 6 minus 5. This will be what? This will be 1. So that means the gradient is 1 at point x1 to be 1. All right. Now, by the formula, y minus y1 is equals to f prime of x1 into x minus x1. That will be y minus, our y1 is what? Minus 2. Then equals to, our gradient now at x1 is 1 into x minus x1. That is x minus, what is x1? 1. I hope you are following. Are you following? Okay. So y minus plus minus is plus 2 equals to x minus 1. So by the time you make y the subject of formula, you have y equals to x minus 1 minus 2. So y will be equals to x minus 3. So the equation of the tangent is y equals to x minus 3. Okay. Now with that, we move to the equation of the normal. Don't forget, I told you that the gradient of the normal is the negative inverse of the gradient of the tangent. Okay, so you don't have to stress yourself. It's very straightforward. Okay, now for the normal now, the formula for normal is y minus y1 is equal to minus 1 over the derivative of f with respect to the point x1 of x minus x1. Okay, so that is going to be what? Y minus y1 is minus 2, as we have done, equals to minus 1 over what did we get at the point x1 when we differentiated our curve? What do we get? We get 1. So into bracket s minus x1 is 1. Very interesting. So this one will give us what? Y plus 2, because minus times minus is plus, is equal to everything here will be minus 1 into x minus 1. So when you expand, you have y plus 2 is equals to minus x plus 1. Yes. So when you multiply this, when you open the bracket, minus 1 times x is minus x. Minus 1 times minus 1 plus 1. So you have y is equal to minus x plus 1. Then take plus 2 to the other side, you have minus 2. So y is equal to minus x minus 2. So this is the equation of the normal. Sorry, 1 minus 2, sorry. That's funny. That's minus 1, sorry. So plus 1 minus 2 is minus 1. That's a mistake, please. Now let's look at example 2 here. Let's look at example 2. Still under equation of tangent and normal. Still under equation of tangent and normal. I want to believe that we are following, please. I want to believe that we are following. Please try to understand this. Try to understand this. Try to follow, please. Try to follow it. It will be useful for you, both in your test and exam. Now, the second example says, find the equation. Find the equation of the tangents. Find the equation of the tangents to the curve y is equal to 2x squared minus x plus 3, which is parallel to the line y is equal to 3x minus 2. Okay, now for this one, example 2, the equation of the curve given to you is this. So we need solution. We need y is equal to 2x squared, minus x plus 3. Now we differentiate straight off. The y dx will be 2 times 2, 4, then x. Subtract 1 from 2 is 1. So you don't write 1 up. Then minus, when you differentiate x, you have 1. When you differentiate 3, you have 0. It's a constant. So the value, our gradients, the rate of change of y with respect to x is 4x minus 1. Fine. This curve is parallel. When you say something is parallel, that means they have the same gradient. That's the meaning. They have the same gradient. It's parallel to this line. It's parallel to this line. And so the line is y equals to 3x minus 2. How do we get the gradient of this line? Using equation of a straight line, y is equals to ms plus c. This is the equation of a straight line, where c is the y-intercept and m is the gradient. So if you compare this with this, comparing them together, you will observe that c is 2, that's intercept, and m is 3. Okay, so that means m is 3. That's what, if you compare this with this, that line with equation of the straight line, m will be 3. So now, and since we are told that the curve is parallel to the line, that implies that they have the same. So that means 4x minus 1 is equal to what? Is equal to what do we have there? What do we have our gradient now? 3. Sorry, it's gradient 3. Okay. So 4x minus 1 is equal to 3. Our gradient is 3. Like I said. So that gives us what? 4x is equal to 3 plus 1. By the time you move this one here, so that will be 4x equals to 4. So x equals to 4 all over 4, which equals to 1. So our x now is equal to 1. Are we following? Fine. Now, when x is now equals to 1, what is our y? We have gotten the value of x now. to be 1. Don't forget, we have gotten the value of x now to be 1. We have gotten the value of x to be 1. So what is y? Don't have to stress ourselves. We are given the equation for the what? The equation of the curve is what? Y is equal to 2x squared minus x plus 3. So when x is 1 now, y will be equal to what? 2 into 1 squared minus 1 plus 3, which equals what? 2 minus 1 plus 3. And 2 minus 1 plus 3 will give us what? This is 1 plus, that is what? 4. Okay? That is going to give us 4. Now we have gotten that the point x and y to be x is 1, y is 4. X is 1 and y is 4. Okay? We have gotten x to be 1 and y to be what? To be 4. Beautiful. So the next thing is now that is the points. So the tangent occurs, you can say the tangent occurs at point x equals to 1, y equals to 4. That is 1, 4. Beautiful. Now using y minus y1 is equals to, the gradient f prime of x1 into x minus x1. Okay? Yeah. So that we now have what? Y minus our y1 is 1 is equal to, now our gradient, the gradient we obtain, what did we get there? We obtain 4x minus 1. Beautiful. Our gradient was 4x minus 1, into bracket x minus 1. I hope you can remember that. Check again. We have our gradient dy dx is 4x minus 1. So that was what we got here. So, and when x is 1, substitution, that what? No, sorry. Y minus y1. Y1 is 4. Sorry about that. Y1 is 4. So we have y minus 4 is equal to 4 into bracket, and this 4 multiplied by 1, which our x is, minus 1, then x minus 1. Beautiful. Beautiful. So we have what? Y minus 4 is equal to 4 times 1 is 4, minus, that's 3, into bracket x minus 1. So by the time we expand this, we have y minus 4 equals to 3x minus 3. So collecting like term, y equals to 3x minus 3 plus 4. So y will be equals to what? Y will be equals to 3x plus 1. So the equation of the tangent is going to be what? Y equals to 3x plus 1. Y equals to 3x plus 1. So now let's look at maximum and minimum values. Maximum and minimum values. Maximum. We will soon call it a day, please. Please bear with me. Maximum and minimum values. Let's look at maximum and minimum values of functions. Let's look at maximum and minimum values of functions. It's kind of unfortunate the network is not friendly. That is unavoidable because we are not the network operator. So please bear with us. Maximum and minimum values of functions. Now, to discuss maximum and minimum values of functions, most times when you draw a graph, particularly all this quadratic graph, you get this is a what? This at a maximum point. If it were this, you get it as a minimum point. Okay? But basically, when you have a function and you want to find the maximum or minimum value of that function, first of all, you must find the stationary point of the function. You find the stationary point of the function. At stationary point, the y dx is equals to what? Is equals to 0. So as to get the point, okay, you must find it will give you the y dx must be equals to 0. Then for you to get the maximum and minimum point, at maximum point, the square y all over the x squared, the second derivative of y with respect to x, will be less than 0. Why at minimum point, the square y, the x square is greater than 0. These are the conditions. At the point of inflection, that's when there's no change at all, the square y, the x square will be equal to 0. So you have to take note of all this. So we are going to combine maximum and minimum point with the point of inflections in this class and in this segment, so as to round it off as fast as possible. So now we have stated all the formulas. Let's look at the example to illustrate what we have written on the board. let's look at the examples to illustrate what we have written on the board, please. Now, the first question here, the question says example, let's say example 4, whatever. Find the maximum and minimum values of y is equals to x cubed minus 6x squared plus 9x plus 9x, Now, we want to find the maximum and minimum values of y. So first of all, we find dy dx will be 3x squared, that is 3 times 1 here, 3. Remove 1 from here. Then minus 2 times 6, 12. Then x, remove 1 from 2, you have 1. Then plus 9. Okay, plus 9. So now, at this point, we get the stationary point. We have to get the stationary point. So our stationary point now, that means when dy dx equals to 0. Okay, so what do we do now? We factorize. Factorization method will be applied here. 3x squared, we are looking for 27, which will give us minus 12x in the cost of adding them together. The minus 9x minus 3x plus 9 equals 0. So we have replaced minus 12x with minus 9x minus 3x. So what is common? We have 3x into x minus, if you divide 9x by 3x, you have 3. Then minus, what is common here? You have 3 into, divide 3, minus 3x by minus 3, you have x left. Divide plus 9 by minus 3, you have minus 3, equals to 0. So virtually, you're going to have what? 3x minus 3 into bracket. You pick one out of this, x minus 3 equals to 0. So you have what? 3x minus 3 equals to 0. So collect like terms, you have 3x equals to 3. X will be what? 3 all over 3, which is 1. Then the next one, x minus 3 equals to 0. X will be what? 3. Okay, with this now, we have gotten the point at which our x is stationary. I mean, our value, our curve is stationary. Now, at this point, we have x equals to 1 and x equals to 3. So now, if you want to get the value of x, of y, the value of y there, we just slot in those values. But now, how do we get the maximum and minimum values of our y? Okay, now let's try when x is equals to 3. Oh, okay, we have written this, right? We have written this. There are two ways of doing this. Let's use the faster approach. Now, we know that, let's check when x is equals to 1. I think we get x equals to 1. Is that what we got here now? Okay. When x equals to 1, beautiful. When x equals to 1, y is equal to 1 cubed minus 6 times 1 squared plus 9 multiplied by 1. This is 1 minus 6 plus 9. This is minus 5 plus, that's 4. Fine. That's 4. When x equals to 3, y equals to 3 cubed minus 6 into 3 squared plus 9 into multiplied by 3. This will be 27 minus 54 plus 27. This one will be 0. Beautiful. Fine. So now, you can see, obviously, we have gotten when x equals to 1, y is equals to 4. When x equals to 3, y is equals to 0. Obviously, from here now, the value of y is greater when x is 1. The value of y is lower when x is equal to 3. Now, let's now check to really validate what we are saying. The square y dx square. Let's find out. I think we got dy dx was what? Our dy dx was 3x squared minus 12x, I think. Then plus 9. Okay, that was dy dx plus 9. So the square y now dx square. So when you differentiate it again, this is what we got when you differentiate this. So differentiating it again now, we have 6x minus 12. Beautiful. 6x minus 12. Okay. I think we have written this. Okay. I hope we are following. All right. So 6x minus 12 is the second derivative of the function when it was differentiated. Okay, so now at x equals to 1, value of our x, the square y dx square, which is 6x minus 12, will be 6 times 1 minus 12. That's what? 6 minus 12, which is what? Minus 6. Fine. At x equals to 3, the square y all over the x square will be 6 times 3 minus 12. That's what? 18 minus 12. And that will be 6. Now, which is greater? Which is greater than 0? Between 6 and minus 6. One is greater than 0, the other one is less than 0. So that means that the square y dx square, if it is greater than 0, that is what? That's the minimum point. Okay? So now that means that we have the minimum point at x equals to 3, and the maximum point at x equals to 1, because at maximum point this will be less than 0 and minus 6 is less than 0. X is 1 there. Now, but the question is, what are the maximum values of x and y? Of y rather, the maximum values of the maximum and minimum values of y. At x equals to 1, what did we get there? I think we got so let me check here. We got 4. Fine. And x equals to 1 gives us minus 6 for the square y dx square. And minus 6 is less than 0. Okay, which is the maximum point. So that means y is equals to 4 at maximum point. Yes. And y is equals to 0. I think the second one is 0 at minimum point. Don't be confused. What do I mean? We obtain y is equals to 4 at x equals to 1. And to establish what we are saying, I told you that whenever the square y dx square is greater than 0, that is minimum point. But the square y dx square is less than 0. So this one is not minimum, it's maximum. So the maximum point of y is when x is 1. And y is equals to 4 there. So the minimum point of the function is when y is equals to 0 and x is equals to what? 3 there. At x equals to 3. So this solves the problem. So the value in question now is the minimum point of the curve for y is 0 at the minimum point, then x is 3. While at the maximum point, y is equals to 4 when x is equals to 1. So it's as simple as that. Okay. I hope you are following. So now let's quickly round off. The last aspect is if you are asked to find the point of inflection, I think you could do that yourself, but let me quickly do it so that I will make sure that no stone is left unturned. I want to ensure that I justify my teaching by making sure that every aspect of this thing is taught. Okay. Now, like I just said, I want to justify my teaching by ensuring that every aspect is touched. Okay. Now, so that you won't have any excuse to say that you did not do well. Now with this, the question says find the maximum and minimum values. Find the maximum and minimum values and the points of inflections. Inflection of y is equals to x cubed minus 6x squared plus 9x plus 1. Want to find that. We're going to find that. Okay. Now, first of all, let's find the stationary point. The y, the x is 3x squared minus 12x plus 9. So when that is equals to 0, when you differentiate plus 1, it will be 0, so we don't need that. So when it equals to 0, you have what? Just the one we have just finished. In fact, this equation is similar to the one we just solved. Very, very the same. So you have what? Factorizing this, you have 3x squared minus 9x minus 3x plus 9 equals 0. I hope you understood how I got this. I replace minus 12x by a factor of 27 when they are multiplied together, but when they are subtracted from each other, they give us minus 12x. So now you have 3x into x, I'm factorizing, minus 3 into x minus 3 equals to 0. So if you get this one, you have 3x minus 3 brackets x minus 3 equals 0. You pick it one by one. So 3x minus 3 equals to 0, 3x equals to 3, x will be 1. Second one, x minus 3 equals to 0, x will be 3. So our x is 3 and 1. Fine. Now at the maximum, the point of inflection, the square y, the x square must be 0. So well, that means we have to differentiate this value again. Differentiate this again. So we have what? That is 6. When you differentiate this, 6x minus 12. That's when you differentiate this, that value. Differentiate again to get a point of inflection. So and must be equal to 0. That's the formula. So we have differentiated the y dx again to give us 6x minus 12 equals 0. So 6x now will be equals to 12. 6x will be equals to 12. 6x will be equal to 12. If 6x equals to 12, what is x? X will be 2. X will be 2. Okay? 6x is equals to 12. X equals to 12 all over 6, which is 2. So our x is 2. Now, when x is 2, what is the value of y? So now go back to. Now putting x equals to 2 into y is equal to s cubed minus 6s squared plus 9x plus 1. So let's put y s equals to 2 there. So y will be what? 2 cubed minus 6 into 2 squared plus 9 times 2 plus 1. This is what? 8 minus 24 plus 18 plus 1. So by the time we add, this is minus 16 plus, that will be 3. So now the question, what is the question saying? The question says that find the maximum and minimum points. Very good. So how do we now know? We have known the point of inflection now. The point of inflection occurs at s equals to 2 and 3. S equals to 2 and 3. This x is 2, y is 3. So the point of inflection occurs. The point of inflection occurs at s equals to 2, y equals to 3. Okay. Now, what the second question? The next thing is find the maximum and minimum values of fine. The maximum and minimum values of y. Fine. You know, we know that the square y all over the s square, if it is greater than 0, that's the minimum value. That's minimum. But if it is less than 0, you know, that's the maximum. Okay. So let's look at which one is correct there. So the square y all over the x square. Let's check which one is maximum, which one is minimum. Okay. Let's check. When differentiated again, we got what? I think we got 6x. That's quite unfortunate. I can't see it again. So we got 6x minus 12. Fine. 6x minus 12 was what we got when differentiated that value again. Fine. So putting our x there now, that will be what? 6 times our x is 2 minus 12. That will be 12 minus 12. That will be 0. I think that's correct. Okay. Now, that is at x equals to 2. Now, when x is equals to when x equals to, we obtain x equals to 1 and 3. Sorry, these are the points for inflation. Sorry, we obtain when we find the what do you call it? When we find our stationary point, we got x equals to 1 and 3. So when x equals to 1, sorry about that. When x equals to 1, 6x minus 12, 6 times 1 minus 12. That's 6 minus 12, which is minus 6. Beautiful. So when x equals to 3, we have 6 times 3 minus 12. That's 18 minus 12. That is what? 6. Fine. So obviously, just like this example is very similar to the previous one, just that that one did not have a point of inflection. So now our maximum point occurs when x is equals to 1, because that one gave us -6, which is less than 0. And our minimum point occurs when x equals to 3, and because that one gave us a positive value that's greater than 0. So that's about that. And what are the values of y at minimum and maximum point? So at maximum point, the maximum is x equals to 1. So y will be equals to what? What's the equation? Let me quickly write out the equations. Y is equals to s cubed, because I've cleaned it up, minus 6s squared plus 9x plus 1. So that will be what? 1 cubed minus 6, 1 squared plus 9 plus 1. I think that will give us 1 minus 6, that's minus 5. That's 4, 5. This will give us 5. So at maximum point, y is equals to 5. Y equals to 5 at maximum point. You can see that x enables us to know which point is maximum and which point is minimum. That's the essence of finding the stationary point first. So at minimum point, our x is 3 there. X equals to 3. And so what is the value? That will be y will be at minimum point 3 cubed minus 6, 3 squared plus 9 times 3 plus 1. So that y will be equals to what? 27 minus, this is 9, 54 plus 27 plus 1. That's plus 28. So this is minus 27, and this will be what? 1. So at y is equals to 1 at minimum point, y is equals to 5 at maximum point. So with this, we have come to the end of the class. Don't forget to click on the notification bell so that each time I upload a new video or there's a for me to have an online session, you'll be informed. And apologies for the erratic behavior of network today. I'm very sure that with time the network will be stable, and so when next we have an online class like this, we will not have any problem. I would advise at this juncture that you go through all the videos so far given, so far posted, so far any aspect of video that I've produced so far in this course. Please take your time. They are supplementary to your notes. They are supplementary and also complementary. So you can use them wisely if you want to. So study them quickly and carefully. Sorry, don't be too quick anyway. Study them carefully. Look at how the methods used in them are used, and try to understand every concept, and believe by the grace of God you are going to excel in your test and examination. So God bless you for having me and for your patience since we started this class. Thank you very much.